So yes, welcome to this class 2. So we will recall the class 1, right? So in the previous class we have seen an introduction to planes, and then we have solved many problems based on some basic formulas using planes. So we will recall all that. So you can see first we have defined what's meant by plane. And the general equation of plane is ax plus by plus cz plus d is equal to 0. If d is equal to 0, the plane passes through origin. If d is not equal to 0, it is not passing through origin. Suppose if you need to find the equation of plane passing through a given point, then equation will be a into x minus x1 plus b into y minus y1 plus c into z minus z1 is equal to 0, where x1, y1, z1 is the given point. Now equation of plane in normal form, so very important. So equation will be lx plus my plus nz is equal to p, where p is the length of perpendicular from the origin. L, n, are direction cosines, right? This you have seen in the previous class. And equation of plane intercept form, it will be x by a plus y by b plus z by c is equal to 1. And the direction cosines of normal, so if d is positive, the direction cosine will be cos alpha is equal to minus a divided by square root of a square plus b square plus c square. And if d is negative, we will have a set of values for cos alpha, cos beta, cos gamma. So based on these 5 definitions, and the very important thing is if ax plus by plus cz plus d is equal to 0 and x cos alpha plus y cos beta plus z gamma cos gamma is equal to p represent the same plane, right? That is if the normal and if this plane represent the same, then they are proportional. That is, the direction cosines of the normal to the plane ax plus by plus cz plus d is equal to 0 are proportional to ABC. So very important note that we come across in problems. And then we have seen some problems based on these 5 concepts. So just recall yesterday notes. And then we have introduced the angle between two planes, right? So if we have two planes, then the angle will be cos theta is equal to, yes, so if I have two planes a1x plus b1y plus c1z plus d1 is equal to 0 and a2x plus b2y plus c2z plus d2 is equal to 0, then cos theta is the angle between two planes. This is given by a1 a2 plus b1 b2 plus c1 c2 divided by square root of a1 square plus b1 square plus c1 square and the square root of a2 square plus b2 square plus c2 square. And these two planes will be perpendicular if theta is equal to 90 degree. If theta 90 degree, then this will be 0. So some quantity by some quantity, if I am getting 0 as an answer, that means the numerator has to be equal to 0. That means if I want to prove the two planes are perpendicular, I need to prove a1 a2 plus b1 b2 plus c1 c2 is equal to 0. And condition for parallel is two planes will be parallel if a1 by a2 is same as b1 by b2 is same as c1 by c2. And we have seen some problems based on subtopic 2. So subtopic 2 is the angle between two planes. So we have seen some problems based on this. So find the angle, find the equation of plane passing through this point and parallel to this point. So we have seen some problem, and a very important problem we have discussed in the at the end of the video. That is, we need to find the equation of plane. Yes. So problem 4 is very important. We need to find the equation of plane passing through the point 2, 2, 1 and 9, 3, 6. So we need to find the equation that has to pass through these 2 points, and also it has to be perpendicular to 2x plus 6y plus 6z plus 9 is equal to 0. That is, this is the equation of plane. They are given an equation of plane which is 2x plus 2y, 2x plus 6y plus 6z is equal to 9. We need to find another plane that has to be perpendicular to this plane. So you can see, if you see this in 3 dimensions. So these two planes are perpendicular. Also, this plane has to contain these 2 points. That is 9, 3, 6 and 2, 2, 1. So we have solved this problem also, and then I have given some exercise problems for you based on finding the equation of plane passing through 2 points and perpendicular to an equation. So for subtopic 1 is we have seen some problems based on general equations of plane. Subtopic 2 is angle between two planes. Now we are going to move on to subtopic 3, right? So subtopic 3 is equation of plane passing through 3 points. So subtopic 3, equation of plane passing through 3 points. So we already seen equation of plane passing through a point, that is a into x minus x1 plus b into y minus y1 plus c into z minus z1 is equal to 0. Now we are going to find equation of plane passing through 3 points. Suppose if 3 points are x1, y1, z1, x2, y2, z2 and x3, y3 and z3. So we need to find the equation of plane. So let us say this is our three-dimensional surface. We need to find an equation of plane that has to pass through all these 3 points. Let us say these are the 3 points. So we need to find a plane that has to pass through these 3 points. So what will be the equation of plane if it has to pass through these 3 points? So I'll use a formula to find the equation of plane passing through 3 points. So the general equation of plane is So what is general equation of plane? So it is ax plus by plus cz plus d is equal to 0. Now if it has to pass through these 3 points, now before I'm giving formula straight away, suppose I'll tell you how the formula came, right? So this is general equation of plane. Our plane has to pass through all these 3 points. That means the first equation will be, first it has to pass through the first point x1, y1, z1. So instead of x, y, z, we just substitute x1, y1, z1. So c z1 plus d is equal to 0. And also it has to pass through this point. So that means ax2 plus by2 plus c z2 plus d is equal to 0. And also it has to pass through this point. That is ax3 plus by3 plus c z3 plus d is equal to 0. So we need to find the equation of plane that has to satisfy all these 3 equations, which it turns out to be simultaneous equations, right? That is ax1 plus by1 plus cz1 is equal to minus d, ax2 plus by2 plus cz2 is equal to minus d, and ax3 plus by3 plus cz3 is equal to minus 3, which is a non-homogeneous system of linear equation. Now if you solve this non-homogeneous system, you will get a general equation of plane. So which it turns out to be the general equation of plane passing through 3 points is given by, so I'll write the formula straight away. So this determinant of x, y, z1, x1, y1, z1, 1, x2, y2, z2, 1, x3, y3, z3, 1 is equal to 0. Right? So if you solve this determinant, you will get an equation of plane that passing through 3 points. Now you may wonder how we got this formula. Now if you solve the system of simultaneous equation, you will get this formula, right? So formula is not required, and also there is no proof for this formula in book also. So you can directly use this formula to find the equation of plane passing through 3 points, right? So you will do some problem based on subtopic 3. So we move on to problems. So problem number 1. Find an equation of plane passing through. Find the equation of plane passing through 1, 0 and 1, 2, 1 and minus 2, 2, minus 1, right? So we need to find the equation of plane that has to pass through these 3 points. So we will do this for solution. So you can see our x1, y1, z1 are 1, 1, 0, and our x2, y2, z2 are, it is 1, 2, 1. So this is x1, y1, z1, this is x2, y2, z2, x3, y3, z3, and our x3, y3, z3 is equal to minus 2, 2, minus 1. So what we need to do is we need to find the equation of plane that has to pass through these 3 points. So we know that equation of plane passing through 3 points is x, y, z1, x1, y1, z1, 1, x2, y2, z2, 1, x3, y3, z3, and 1 is equal to 0, right? Now we will solve this equation. This will be determinant of x, y, z1, x1, y1, z1, 1. This will be 1, 1, 0, 1, right? I'm just substituting x1, y1, z1 in the formula. And this will be 1, 2, 1, 1. This will be minus 2, 2, minus 1, and 1 is equal to 0. Now we will expand this determinant. So if we expand this determinant, this will be x into determinant of, so this column and this row will get vanished. So we will have 1, 0, 1, 2, 1, 1, and 2, minus 1, 1, right? So if we expand this x, this column and this row will get vanished. So we will have 1, 0, 1, 2, 1, 1, minus, and 2, minus 1, 1. Second term will be minus, so determinant of, so if I expand this term, so we will have this column and this row will get vanished. So we will have 1, 1, minus 2, 0, 1, minus 1, 1, 1, 1, plus z into this column and this row will get vanished. So we will have 1, 1, minus 2, 1, 2, 2, and we will have 1, 1, 1, plus second, third, fourth term will be minus, right? For every second term, that is second term, fourth term, that is formula will be minus 1 whole power n. So if for minus 1 whole power n plus 1, right? Minus 1 whole power n plus 1 into determinant of that term. So the second term will be minus, fourth term will be minus, and fifth term will be, sixth term will be minus. Next one determinant. So minus 1 into, don't forget to put minus here, right? So second term and fourth term and sixth term, all the even terms are minus of that term. So minus, so this column and this will get vanished. So we will have 1, 1, 0, 1, 2, 1, minus 2, 2, minus 1 is equal to 0. So now we will expand this. So again it's a 3 cross 3 determinant. So I'll do this straight away. So first we need to expand 1. So 1 into this column and this will get vanished. So we will have this 2 cross 2 determinant. So this will be 1 minus of minus 1. This will be 1 plus 1. So minus 0 into anything is 0, plus 1 into, to expand this term, this column, this will get vanished. So we have this 2 cross 2 determinant. This will be minus 2. In between we have minus. So minus 2, minus 2. So we will have minus 4. So minus y into, so to expand this 1, so this column, this will vanish. So we have this 2 cross 2 determinant. So 1 into 1 is 1. This will be minus 1. In between we have minus. So it will be plus 1. So minus 0 into anything is 0. Plus 1 into, if I expand this term, this will be minus 1 plus 2. So minus 1 plus 2 will be plus 1. Plus z into, so if I expand this term, this will be 1 into this column, this will get vanished. So we have 2 minus 2. So 2 minus 2 is 0. Minus 1 into, so if we expand this term, this column, this will get vanished. So we have 1 plus 2. So 1 plus 2 is 3. So plus 1 into, this will be 2 plus 4, right? 2 plus 4 minus 1 into, this will be 2 into minus 1 is minus 2. So minus 2 is minus 4. 1 into minus 4 minus 1 into, this will be minus 1 plus 2. Minus 1 plus 2 is 1 plus 0 into anything is 0 is equal to 0. Now we just simplify this. So we will have x into, this will be 2. So 2 minus 4. We will have minus 2 minus y into, so here we will have 2 plus 1. So 2 plus 1 will be plus 3y. Right. Here we will have 1 plus 1, 2. 2 plus 1 is 3. And let's check here. So expand y. Okay, right. So this will be plus z into, this will be 6 minus 3 is 3, minus 1 into, this will be minus 4 minus 1. So minus 4 minus 1 will be minus 5 is equal to 0. So our answer will be minus 2x minus 3y plus 3z plus y is equal to 0, or if you multiply by minus, so this is the equation of plane that is passing through these 3 points. Right? So this is equation of plane and passing 3 points. A very easy problem. So you just remember the formula and expand this 4 cross 4 determinant. You will get again a 3 cross determinant. To expand this, you will have everything in terms of x, y, z and constant. That will be my equation of plane passing through these 3 points. On to problem number 2. Show that the 4 points. So the 4 points 0 minus 1 0, 2 1 minus 1, 1 1 1 and 3 3 0 are coplanar. Right? So we need to show that these 4 points are coplanar. So what is coplanar? So coplanar is if all the points lie in the same plane. If all the points lie on the same plane, it is called coplanar, right? So what we're going to do is, first we're going to find an equation of plane that is passing through these 3 points, right? So what we're going to do is, I'm going to find an equation of plane that is passing through these 3 points. Let's say this is A, this B, this C and D. So what I'm going to do is, I'm going to find an equation of plane that is passing through these 3 points, and I'm going to say, after finding the equation of plane passing through these 3 points, I'm going to say that this D point also lies in this plane. How can I say this D point also lies in the plane? That is, I need to show that this point has to satisfy the equation of plane passing through these 3 points. If that happens, then we can say these 4 points are coplanar, right? I'll repeat. I'm going to find an equation of plane. You can take any 3 points. I'm taking the first 3 points. So what I'm going to do, you can take any 3 points. I'm taking the first 3 points. So I'm going to find an equation of plane passing through the 3 points, and I'm going to show the 4th point also satisfies the equation of plane passing through these 3 points. That means all 4 points lie on the same plane, right? Solution. So first we will find equation of plane passing through 0 minus 1 0, 2 1 minus 1 1 1 1, and we will show that the 4th point 3 3 0 satisfies the equation of plane, right? That's the equation of plane. So first we will find equation of plane passing through these 3 points, right? So equation of plane, so passing through 0 minus 1 0, 2 1 minus 1 1 1. So I can do this very quickly. So the equation will be x y z 1, and do this directly. So it will be 0, minus 1, 0, 2, 1, minus 1, 1, 1, 1, 1, 1, is equal to 0. Now expand this determinant. This will be x into determinant of this column, this will get vanished. So we will have minus 1, 0, 1, 1 minus 1, 1, 1, 1, 1, minus y into this will be 0, 2, 1, 0 minus 1, 1, 1, 1, 1, plus z into 0, 2, 1, minus 1, 1, 1, this will be 1, 1, 1, minus 1 into 0 minus 1, 0, 2, 1 minus 1, 1, 1, 1 is equal to 0. Now expand this determinant. This will be minus 1 into this will be a minus 1 minus 1, so minus 2. So second term will be 0 plus 1 into this will be 1 plus 1, so 1 plus 1 will be 2, minus y into, so these two terms I don't need to expand, so we have only 1 in the last, so it will be 2 plus 1, so 2 plus 1 is 3 plus z into, so again I don't need to expand 0, my second term will be minus, already you have minus here, so it will be plus 1, so 2 minus 1 is 1, plus 1 into 2 minus 1 is again 1, minus 1 into, so second term, the expand second term will be 1 into 2 plus 1, which is 3, is equal to 0. So this will be, here you will have 2, this will be 2, so 2 plus 2 is 4, right, 2 plus 2 is 4, so we will have 4x minus 3y, and here you will have 1 plus 1 is 2, so we will have 2z, and here you will have minus 3 is equal to 0. Is the required equation of plane passing through 3 points, right? Now we need to show the fourth point, that is D point, 3, 0 lies on equation 1. Let's say this calls as equation number 1. Now we'll just substitute this x, y, z in the equation. So we will have 4x minus 3y equal to 0. So we will have 4 into 3 minus 3 into 3 plus 2 into 0 minus 3, which will be 12 minus 9 minus 3, so which is 12 minus 12, which is 0, right? Therefore the fourth point satisfies this equation. That means the fourth point lies in this plane. Therefore the points are coplanar. 4 points are coplanar because all 4 points lie on the same plane, right? So move on to problem number 3. So problem number 3 is so find the equation of plane passing through 0, minus 1, minus 1, 4, 5, 1 and 3, 9, 4, and find the direction cosines of the normals, right? So we need to find the equation of plane that has to pass through these 3 points. Also we need to find the direction cosine of the normal to that plane, right? So solution. So first you find the equation of plane passing through these 3 points. So I'll just take an exercise, right? So you just find equation of plane passing through 0, minus 1, minus 1, 4, 5, 1, 3, 9, 4, So just use the formula x, y, z1, x1, y1, z1, 1, x2, y2, z2, 1, x3, y3, z3, 1 is equal to 0. Now if you use this formula, you will get an equation as 5x minus 7y plus 11z plus 4 is equal to 0. Right? Now we need to find the directional cosines of normals to this plane. So to find direction cosines of normals on the plane 5x minus 7y plus 11z plus 4 is equal to 0. So we already seen how to find the direction cosines of normal to the plane. If d is positive, we will have one set of value. If d is negative, we will have another set of values. So if d is positive, our cos alpha will be minus a divided by square root of a square plus b square plus c square. Cos beta will be this formula, cos gamma will be this formula. So we need to find the equation of direction cosines of normal to this plane. So you can see our d is positive. So if d is positive, my direction cosines will be this a, this b, this c, and this d. So we will have minus a divided by square root of a square plus b square plus c square minus b divided by square root of, this will be minus c divided by square root of a square plus b square plus c square. To substitute, this will have minus 5 divided by square root of 5 square plus 7 square plus 11 square. So 25 plus 49 plus 121. So we will have root 195. This will be 7 divided by root 195, and this will be 11 divided by root 125. These are the direction cosines of normals to this plane. I will give some exercise problems to you. Find an equation of plane passing through passing through 4, 5, 1, 3, 9, 4, minus 4, 4, 4, and hence show that 4 points 0, minus 1, 1, 4, 5, 1, 3, 9, 4, minus 4, 4, 4 lie on a same plane. Right, just find the equation of plane passing through these 3 points and show that this point satisfies this equation. So problem 2 will be find show that minus 1, 4, minus 3, 3, 2, minus 5, minus 5 are coplanar. Right, so just take these 2 problems exercise. So I'll move on to the next subtopic, which is equation of plane passing through line of intersection of 2 given plane. Right, the first topic is we have solved problems based on general equation of planes. Second is angle between the planes. If you see the question, first you need to understand, first you need to find which subtopics it comes under, right? So we'll move on to subtopic 4. Subtopic 4 is equation of plane. Equation of plane passing through the line of intersection of two given points. Right? So just go through the topic once again. Equation of plane passing through line of intersection of two given plane. Right? So that means suppose if I have a two plane, let us say this is one plane, right? Let us say the another plane is somewhere around here. Now we need to find an equation of plane passing through the line of intersection of these two. That is, we need to find another equation that has to pass through the line of intersection. This is the line of intersection, right? So you can see at this point our plane is intersecting. We need to find another equation. That's this equation we are finding that has to pass through the line of intersection of both the planes, right? So equation of plane, we need to find this equation that has to pass through the line of intersection of two given planes. So they will give two given planes. We need to find another equation of plane that has to pass through both these two planes, right? So let the two planes be. Let us say the two planes. Let us say that there are two planes P1, P2. So what is general equation of first plane? Let us say this A1x plus B1y plus C1z plus D is equal to 0. A2x plus B2y plus C2z plus D2 is equal to 0. Let us say these are the two equations of plane that they are given. Now we need to find an equation of plane that has to pass through the line of intersection of these two planes, right? And that is, we need to find, then if we solve this equation, P1 plus lambda P2 is equal to 0. This is the required equation of plane passing through 2 points. This is the required equation of plane passing through the line of intersection of two given points, right? So to solve this equation, we need to find lambda. After finding lambda, if I add these two planes, we will get the required equation of plane passing through two given planes, right? So now we move on to problems based on these subtopics. So problem number 1. Find the equation of plane passing through the point of intersection of the plane 2x plus 3y minus 4z is equal to 1, 3x minus y plus z plus 2 is equal to 0, and the point 0, 1, right? Therefore, understand the question. So find the equation of plane passing through the point of intersection of. So let us say the two planes are, that is somewhat around these are the two planes. Now we need to find another equation that has to pass through this point of intersection, but also this plane should contain the point 0, 1, 1, right? So find the equation of plane passing through the point of intersection of the plane. This is the first plane they have given. Second plane they have given. We need to find another plane that has to pass through the point of intersection. Also, this plane has to contain the point 0, 1, 1, right? They are given P1 as 2x plus 3y minus 4z minus 1 is equal to 0. And they are given P2 as 3x minus y plus z plus 2 is equal to 0. Now we need to find equation of plane passing through point of intersection. The required plane is, it is P1 plus lambda P2 is equal to 0. What is P1? So 2x plus 3y minus 4z minus 1 plus lambda into P2. P2 is 3x minus y plus z plus 2 is equal to 0. This is the equation we need to find. If we find lambda, then we can easily solve this equation. Yes, we need to add the equation. Now we need to find lambda. Now to find lambda, it is given that 0, 1, 1 lies in the point of intersection of plane. That means, so this is first equation, then 0, 1, 1 lies in 1 because the required plane that we need to find has to pass through this point. That means it has to satisfy this equation, right? That means the point 0, 1, 1 lies in this equation. Just substitute this. So we'll have 2 into 0 plus 3 into 1 minus 4 into 1 minus 1. We just substitute x, y, z in the equation. Plus lambda into 3 into 0 minus y plus 1 plus 2 equal to 0. So you can see this term will get vanished. So we will have 3 minus 4 is minus 1. Minus 1 minus 1 is minus 2. So minus 2 plus lambda into, here we will have this 2 will get cancelled. So we will have only 2 is equal to 0. That means 2 lambda is equal to 2. That means lambda is equal to 1. Right? Now substitute lambda is equal to 1 in equation number 1. We will have, so we will have 2x plus 3y minus 4z minus 1 plus 1 into 3x minus y plus z plus 2 is equal to 0. Now we just add the like terms. So 2x plus 3x is 5x, 3y minus y is plus 2y, minus 4z plus z is minus 3z, minus 1 plus 2 minus 1 plus 2 is plus 1 is equal to 0. This is the required equation of plane that is passing through the 3 points, and also it will contain the point 0, 1. Right? So problem 2, we just take this as exercise problem. Find equation of plane passing through x plus passing through the point of intersection, passing through the point of intersection of x plus y plus z is equal to 6, 2x plus 3y plus 4z is equal to 5, and the point 4, 4, 4, right? The same question. So should be a new equation will be P1 plus lambda P2 is equal to 0. Now to find lambda, it is given that our plane has to pass through this point. So we just substitute x, y, z to be equal to 4, 4, 4. You will get lambda. So the answer will be 29x plus 23y plus 17z is equal to 236 is the required answer. So if you want more question, I can also give some other road question and this problem exercise. Same method. Find equation of plane. So same problem. Instead of these two plane, the new plane will be 2x plus y plus 2z is equal to 9. 4x minus 6y minus 4z is equal to 1. The point 3, 2, 1. That is everything is same. Find the equation of plane passing through the point of intersection of these two planes, and it contains the point 3, 2, 1. Okay? So just find the answer. So I'll move on to the fourth problem. So find the equation of plane passing containing the line of intersection of the plane x plus 2y plus 3z minus 4 is equal to 0 and 2x plus 5 minus z plus 5 is equal to 0 and is perpendicular to to 5x plus 3y plus 6z plus 8 is equal to 0. A very important problem. So just try to solve this problem in your own, right? So we'll do this, but you just think how we can solve the problem, right? The only thing is we need to find lambda. So to find lambda, in the previous problem they were given the point of intersection. Using the point of intersection we have found lambda, right? Now here to find lambda we have given another condition, another clue that the plane passing through the point of intersection is perpendicular to another plane 5x plus 3y plus 6z plus 8 is equal to 0, right? So first we will find equation of plane contains the line of intersection of these two points, right? So first we will find the line of intersection of plane. That is, we have two planes P1. So P1 is x plus 2y plus 3z minus 4 is equal to 0 and our P2 is 2x plus y minus z plus 5 is equal to 0. Now we find the equation of plane and then the line of intersection of plane. So it will be P1 plus lambda P2 is equal to 0. So that is, this will be x plus 2y 3z minus 4 plus lambda into 2x plus y minus z plus 5 is equal to 0, right? Now if we add this we will have, so if you take x, it will be 1 plus 2 lambda into x, we will have 2 plus lambda into y, and here you will have, if I take z common, we will have 3 here, and if I take z common here, we will have minus lambda into z plus constant term minus 4 plus 5 lambda is equal to 0, right? So now this is the equation of plane we need to find. Now they are given that it is this equation, that is, let us say this equation number 1. Equation number 1 is perpendicular to 5x plus 3y plus 6z plus 8 is equal to 0. That means the dot product for these two will be 0, right? So if two planes are perpendicular, we know that a1 a2 plus b1 b2 plus c1 c2 is equal to 0, right? So we know that if two planes are perpendicular, a1 a2 plus b1 b2 plus c1 c2 is equal to 0. So a1 is 1 plus 2 lambda. This is a1 b1 c1 d1, and this is a2 b2 c2 d2. Now so the substitute will be 1 plus 2 lambda into 5 plus 2 plus lambda into 3 plus 3 minus lambda into 6 is equal to 0, right? So a1 a2, so 1 plus 2 lambda into 5, 2 plus lambda into 3, 3 plus lambda into 6. So it will be 5 plus 10 lambda plus 6 plus 3 lambda, 18 minus 6 lambda is equal to 0. Now 5 plus 6 is 11, 11 plus 18, it will be 29. This will be 10 lambda, 13 lambda. So 13 lambda minus 6 lambda. So 13 lambda will be plus 7 lambda is equal to 0. So this implies 7 lambda is equal to minus 29. This implies lambda is equal to minus 29. That's it, right? So in the previous problem, they are given the point of intersection. Using that, we have found lambda. Here they are given that this equation is, that the required equation is perpendicular to this plane. That means we are using this concept to find lambda. Now substitute lambda in equation number 1. We can find the general equation of plane, right? The equation of plane, required equation of plane. So this will be, what is the required equation of plane? It is 1 plus 2 lambda into x, 2 plus lambda into y, 3 minus lambda into z. This is equation number 1, right? So you can see equation number 1 is 1 plus 2 lambda into x plus 2 plus lambda into y, 3 minus lambda into z, minus 4 plus 5 lambda is equal to 0. Now substitute lambda here. So we will have 1 plus 2 into minus 27 by x, 2 minus 29 by 7, 3 plus 29 by 7, and substituting lambda is equal to minus 29 by 7. Now just simplify this equation, you will get the answer. Now this will be 7 minus 58, right? So 7 are 7. So 7 minus 58. We will have minus 51 by 7x. 14 minus 29. 14 minus 29 will be minus 15 by 7y. 21 plus 29 will be plus 50z. Plus this will be minus 28 and this will be minus 29 into 5. So 145, right? 145. Start this, you will have minus 173 by 7. Now if you take LCM on 7, if I take 1 by 7 common, if you bring it to this side, 7 will get vanished, and if you multiply with minus, you will have 51x, 15y, minus 50z, plus 173 is equal to 0 is the required equation. Okay. So let's go to the problem again, very important problem. Move on to the fifth problem. The plane x minus 2y plus 3z is equal to 0 is rotated through right angle about its line of intersection. With the plane 2x plus 3y minus 4z plus 5 is equal to 0. Find the equation of plane in new position. Same problem, you don't get confused with the question, right? So actually the plane is in this position, x minus 2y plus 3z is equal to 0. You don't worry about this statement. It's rotated through right angle above its line of intersection with the plane 2x plus 3y minus 4z minus 5 is equal to 0, right? So don't worry about this. So we will have two planes. Right? Let us say this equation is x minus 2y plus 3z is equal to 0. And this equation is 2x plus 3y minus 4z minus 5 is equal to 0, right? So we need to find the equation of plane that passing through these two planes and at right angles to this plane, that's it. And at right angles to this plane. So first I will write and then I will explain this statement. Okay? So same question they've asked in different manner, right? So same thing we're going to do. So here we need to find equation of plane passing through the line of intersection of the two planes x minus 2y plus 3z is equal to 0 and 2x plus 3y minus 4z minus 5 is equal to 0, and it has to be perpendicular. It has to be perpendicular to x minus 2y plus 3z is equal to 0, right? So you can see the plane, this plane is rotated through right angle about this line of intersection with the plane this. Find the equation of plane new position, right? So if this plane is rotated at right angle, so that means the intersection of these two planes and this plane is rotated at right angle. That means the intersection of these two, the intersection plane and this plane is rotated. That means these two planes are at right angles, right? We need to find the equation of plane in new position. Same problem they asked in different manner, right? So first we will find, so what is P1? So we will find P1 plus lambda P2 is equal to 0. This is all we need to find, and this has to be perpendicular to x minus 2y plus 3z is equal to 0 because it is rotated through right angle. So that means this will be 2x plus 3y minus 4z minus y plus lambda into P2 is 2x plus 3y minus 4z minus 5 is equal to 0. Now if we take x common, we will have 2 plus 2 lambda into x, 3 plus 3 lambda into y, and here we will have minus 4 lambda into z, and the constant will be minus 5 lambda is equal to 0. Now it is perpendicular to, because it is rotated to right angle, right? So it is perpendicular to x minus 2y plus 3z is equal to 0. Let us take this equation number 2, this equation number 1. So from 1 and 2, A1, A2, same problem, right? B1, B2, C1, C2 is equal to 0. That means 2 plus 2 lambda into 1 plus 3 plus 3 lambda into minus 2. This is A1, A2, A1, B1, C1, D1. This is A2, B2, C2. So this plane is passing through origin. That is why we don't have D term here. So A1, A2, B1, B2, C1, C2. So we will have minus 4 lambda into 3 is equal to 0. So this will be 2 plus 2 lambda minus 6 lambda minus 12 lambda is equal to 0. So 2 minus 4 minus 16. So this will be minus 4 lambda minus 16 lambda is equal to 0. So minus 16 lambda is equal to 16. That means lambda is equal to minus 1. So substitute lambda is equal to minus 1 in equation number 1. So this will be 2 plus 2 into minus 1 into x just applying lambda is equal to minus 1 in this equation, just this equation. So you can see that actually P1 is x minus 2y plus 3z, we can add 2x plus 3y minus 4. Sorry, I have written both the same equations, 2x plus 3y minus 4z plus 5, 2x plus 4y. It has to be x minus 2y plus 3z. It seems to be everything wrong, right? Because P1, P2 are these two things, I have written both the same things. Okay. So if you do this in the same manner, I'll just write the answer here. So you will have, so this will be x minus 2y plus 3z plus lambda into 2x plus 3y minus 4z minus y is equal to 0. So if you compare this, you will have 1 plus 2 lambda into x minus 2 plus 3 lambda into y plus 3 minus 5 lambda, 3 minus 4 lambda into z and minus 5 lambda is equal to 0, right? 3 minus 5 lambda. Now it is perpendicular to x minus 2y plus 3z is equal to 0. That means a1 a2 plus b1 b2 plus c1 c2 is equal to 0. Now if we make dot product, we will have 1 into 1 plus 2 lambda and minus 2 into 3 lambda minus 2 plus 3 into 3 minus 4 lambda is equal to 0, right? So you can see 1 into 1 plus 2 lambda minus 2 into 3 lambda minus 2 plus 3 into 3 minus 4 lambda. So this makes simplification, you will get lambda to be equal to 7 by 8. Now substitute lambda in equation number 1. So you will get a new equation. So the answer will be, substitute lambda in equation number 1, you will get 22x plus 5y minus 4z is equal to 35x. This is the equation of plane that is passing through these 3 points. So I'll give one more problem exercise. Find equation of plane passing through the line of intersection of the planes 2x minus y is equal to 0, 3x minus y is equal to 0, and perpendicular to 4x plus 5y minus z is equal to 8, and the answer will be 28x minus 14y plus 9z is equal to 0. This is the equation of plane passing through point of intersection of the planes. Move on to 7th problem. So find the equation of plane passing through x plus y plus z is equal to 1, 2x plus 3y minus z plus 4 is equal to 0, and parallel to x-axis, y-axis. Okay. So that is first we need to find the equation of plane passing through the point of intersection of these two lines. So first we will do the first part. So P1 plus lambda P2 is equal to 0. This is the equation we need to find. This will be x plus y plus z minus 1 plus lambda into P2 is 2x plus 3y minus z plus 4 is equal to 0. Now in the first problem, to find lambda, they have given the point of intersection. In second set of problem, they have said that the two planes, the point of intersection of the planes is perpendicular to some plane. Using dot product, we have found lambda. Now here, so we will move on to the first case. So before that, we will simplify this. So 1 plus 2 lambda into x plus 1 plus 3 lambda into y plus 1 plus 3 lambda into z. 1 minus lambda. Minus lambda into z. The constant terms are minus 1 plus 4 lambda is equal to 0. Now first we need to find an equation of plane that is parallel to x-axis. It is parallel to x-axis, right? So you just note this line. If the plane is parallel to x-axis, then it is perpendicular to yz plane. Right? Suppose if we have a plane, if we have x-axis, y-axis, z-axis, you just see this 3 dimension, right? In 2 dimension, it is hard to visualize. If this plane is parallel to x-axis, suppose if we have a plane that is parallel to this axis, then this plane is perpendicular to y-axis and z-axis, right? It is very hard to visualize in 2 dimension. So if you see this in 3 dimension, it will be true, right? So again, if the plane is parallel to y-axis, then it will be perpendicular to xz plane, and if the plane is parallel to z-axis, then it will be perpendicular to xy plane. Right? It is true for all axes. If the plane is parallel to x-axis, it will be perpendicular to yz plane. If the plane is parallel to y-axis, it will be perpendicular to xz plane. If the plane is parallel to z-axis, it will be perpendicular to xy plane. So, what is yz plane? So, what are the coordinates for yz plane? Since it is perpendicular to yz plane, so x will be equal to 1. Y will be equal to 0, z will be equal to 0, because our plane is parallel to x-axis, right? So these are the conditions for x, y, z. If the plane is parallel to y-axis and if it is perpendicular to xy plane, my coordinates will be x is equal to 0, y is equal to 1, z is equal to 0. Now this plane is perpendicular, right? That is 2, this 1. Now 1 and 2 are perpendicular. 1 and 2 are perpendicular. Now to make a dot product, it will be equal to 0, right? That means 1 plus 2 lambda into 1 plus 1 plus 3 lambda into 0. You see this as a plane, right? That is x plus 0 plus 0 plus 0 is equal to 0. Ax plus by plus z is equal to 0. So this will be again 1 minus lambda into 0 is equal to 0. So we will have 1 plus 2 lambda is equal to 0. That means lambda is equal to minus 1 by 2. Now substitute lambda is equal to minus 1 by 2 in equation number 1. So we will get the required equation, right? So 1 plus 2 into minus 1 by 2x, 1 plus 3 into minus 1 by 2 into y, 1 plus 1 by 2 into z, minus 1 plus 4 into minus 1 by 2 is equal to 0. Now I think you can simplify this, right? This will be 2 to get cancelled. This x term will get vanished now. So for y term we will have 2 minus 3. So it will be minus 1 by 2 y. This will be plus 3 by 2 z. And this will be minus 1 minus 4. So minus 2 minus 4, minus 6 by 2. So minus 6 by 2 is minus 3. So this is equation of plane, right? Others we can also multiply minus. Now we need to find another equation that is parallel to y-axis. So if it is parallel to y-axis, then it will be perpendicular to x z plane. What are the coordinates? X is equal to 0, y is equal to 1, z is equal to 0. Now, 1, let us say this is equation number 3. Now, 1 and 3 are perpendicular, right? 1 and 3 are perpendicular. Because this equation is common, first equation is common, this equation is common, we are finding the equation of plane that is parallel to this plane and perpendicular to this plane. Or you can also use some other concepts also, that is, if two planes are parallel, then the direction a1 by a2 is same as e1 by b2 is same as e1 by c2. Now we find the equation of plane that is parallel to x-axis, and you use the condition a1 by a2 is equal to b1 by b2 plus c1 by c2. In that way also you can find lambda. So again, if you make dot product with 1 and 3, you will get lambda is equal to minus 1 by 3, and substitute in equation number 1, you will get the required equation of plane. You will get the required equation of plane, right? Now last problem, with this we will wind up this video. I think this is 8th problem. So find the equation of plane passing through the point passing through the point 2, minus 3, 4 and normal to the line joining b, 4, minus 1, 2, minus 1, 6, right? That is, we need to find an equation of plane that has to pass through this point, right? So that means our plane has to contain the point 2, minus 3, 4, and also it has to be normal to the line joining these points, right? That is, let's say this is our normal, right? This point, this line is normal because there is a dot that I am bigger. Suppose if I have a plane and this has to contain the point 2, minus 3, 4. Let's say this is our normal, right? Let's say this is our normal. This is 90 degree. This is normal. Find the equation of plane passing through the point of distance 2, 3, minus 4 and normal to the line joining. Suppose we need to find the line, if you join the line with these 2 points, and that line has to be normal with this plane, right? Suppose if you have, this is the line joining those 2 points, it has to be normal with this plane, right? So it has to be normal with this plane. So there are 2 conditions. The first is it has to contain 2, minus 3, 4, and let us say these are the 2 points A, B. The line joining these points must be normal to the line, must be normal to the plane, right? This is the one we need to find. Now, solution. Now, first we will find the direction ratios of line joining 2 points, right? So just remember the concept. The direction ratio of line joining 3, 4, minus 1, 2, minus 1, 6. Nothing but the difference of the coordinates. So it will be the question is 4 minus 1, 2. The question wrong. We correct the question. Okay, we will do this. So first we will find the direction ratios of line joining these 2 points, right? Okay, the question is correct. First we will find direction ratios of line joining these 2 points. So it is nothing but the difference of these two terms, right? So it will be 3 minus 2, 4 minus half minus 1, minus 1 minus 6. It will be 1, 5 and minus 7. So this is the direction ratios for the line joining these 3 points, right? Now find the equation of plane passing through the point. Now our plane has to pass through this point, right? Our plane has to pass through this point. Okay. Now I'm going to use the note that I've already given, that the normal to this plane, is parallel to the line. That is, we'll go on to previous class 1 and then we will see one note. So this is the note, right? If ax plus by plus c is equal to 0 and x cos alpha plus y cos beta refers to the same plane, then you can see the direction cosines of the normal to the plane are proportional to ABC, right? I'm going to use that concept now. If these are proportional, that means it is parallel, right? A1 by A2 is equal to B1 by B2 is equal to C1 by C2. So I'm going to use that. The normals to this plane is parallel to the line, right? That means we just form, this is ABC, right? So equation will be x plus 5y minus 6, x plus 5y minus 7z plus k is equal to 0, because it is parallel. Why? Because you can see this plane, now the normal to this plane is parallel to the line. Which line? That is, these are parallel. That is, this normal and this plane are parallel, right? So that means the normal to this plane is parallel to that line. So it will be x plus 5y minus 7 plus k is equal to 0. Now to find k, we will substitute the point 2 comma minus 3 comma 4, because this point lies in this plane, right? Because this point lies in this plane. So always remember that the plane and normal are always parallel. That is, the plane and normal are always parallel. So we know that we know ABC, because direction ratios are ax plus by plus cz. Equation of plane is ax plus by plus cz plus t is equal to 0. This ABC are direction ratios, right? That I already discussed the previous class. Now, since this and this are parallel, the only thing that changes the constant. That means x plus 5y minus 7z plus k is equal to 0. Now to find k, this point lies in equation number 1. So substitute that point here to find that point. So it should be 2 plus 5 into minus 3, 7 into minus 4 plus k is equal to 0. So we will have 2 minus 15 minus 28 plus k is equal to 0. So this will be minus 41, right? Minus 41 plus k is equal to 0. That means k is equal to 41. So therefore, required equation is x plus 5y minus 7z plus 41 is equal to 11. I'm just substituting k in equation number 1. You will get this, right? Let me give you one more problem for exercise. Exercise number 9. Find the equation of plane passing through 2 comma minus 3 comma 1 and normal to the line joining same problem, I just change the numbers, right? So what's the solution? So what are the direction ratios? Direction ratios are 3 minus 2, 4 minus half minus 1, minus 1 minus 5. So it will be 1 plus 5 minus 6. So this required equation is x plus 5y minus 6z plus k is equal to 0, because these direction ratios to the plane are parallel, so it will be plus k. Now to find k, to substitute the point 2 comma minus 3 comma 1 in 1, you will find k. So k turns out to be minus 19. Substitute k back to the equation number 1. So equation number 1 will become x plus 5y minus 6z minus 19 is equal to 0 is the required equation of plane, right? Now we'll do last problem and then exercise problem number 10. To find the equation of plane, passing through 4 comma minus 1 comma 2 and perpendicular to the line joining 1 minus 5 10 2 3 4 and find the angles which it makes with coordinate axis. So if you have two line joining 2 points, you always find direction ratios. Direction ratios will give the value of ABC. From that you can easily find, right? So what we need to do is, first we need to find an equation of plane that has to pass through the point 4 comma minus 1 comma 2, right? That has to pass through the point 4 comma minus 1 comma 2, and this plane has to be perpendicular to the line joining those points. Suppose if we have two line joining point, so everything is 3 dimension, right? It's very hard to visualize. Now this line joining these 2 points has to be perpendicular to this plane, right? So find the equation of plane passing through 4 minus 1 2 and perpendicular to the line joining this point, right? So what is the equation of plane passing through 4 comma minus 1 comma 2? So it is a into x minus x1 plus b into y minus y1 plus c into z minus z1 is equal to 0. So we substitute, we will have a into x minus 4 plus b into y plus 1 plus c into z minus 2 is equal to 0, right? Now it is given that it is perpendicular to this line joining these 2 points, right? So what is the direction ratios? Direction ratios of line. So it is 1 minus 5 10 minus 2 3 4. Difference between the line joining point is the direction ratios. So minus 1 minus 8 10 minus 4 is 6. These are A, B, C. Now these two are perpendicular, right? Find the equation of plane passing through this point, and 1 and 2 are perpendicular. 1 and 2 are perpendicular. That means A1 A2 plus B1 B2 plus C1 C2 is equal to 0. A1 A2 plus B1 B2 plus C1 C2 is equal to 0, right? Now if we use this, here we have, there is no constant, right? If we use this, we will have x minus 4 a into minus 1 b into minus 8 plus c into 6. So you will have one equation in terms of ABC. So with this result, it is not enough to find all three constants, right? So if you use this, we will have x minus 4 into minus 1 we will try to use this, right? We will try to use this. So if you make a dot product with these two terms, a1, a2, b1, b2, c1, c2, you will have only this equation, which is minus a minus 8b plus 6c is equal to 0, right? But this is not an equation of plane because it has to be in terms of x, y, z. So I'm going to use different method to find equation of plane, right? Now we know that the direction cosines of a normal to the plane are proportional to ABC. I'm going to use the note that I have given in the very first class, that direction cosine of normals or direction ratios of normal to the plane are proportional. That is a by minus 1 is equal to b by minus 8 is equal to c by 6. Let us say this is equal to some k, and this k is greater than 0, right? Now we can find ABC in terms of minus k. That means a is equal to minus k, b is equal to minus 8k, c is equal to 6k. Now you substitute this ABC. Substitute ABC in equation number 1. So what is equation number 1? A into x minus 4 plus b into y plus 1 plus c into z minus 2 is equal to 0. Now we can do anything, but we need to get an equation in terms of x, y, z. It will be minus k into x minus 4 minus 8k into y plus 1 6k into z minus 2 is equal to 0. Now if I take k common, now I can take k common. So we will have minus of x minus 4 minus 8 into y plus 1 plus 6 into z minus 2 is equal to 0. Now this k is not equal to 0. That means this term has to be equal to 0. So minus of x minus 4 minus 8 plus 6 into z minus 2 has to be equal to 0. Now to solve this equation, you will have x plus 8y minus 6z plus 16 is equal to 0. Right? Now you try to do in some other method also. I think you can do this problem with similar same different manner also. These are the constants ABC, right? Minus 1, minus 8, 6. Now to make a dot product, we will have Yes, I think you can make a dot product with these two terms also to find this equation. Let's say try to, as sum is over now, let's try to make a dot product with these two terms. So it will be x minus 4 into minus 1, y plus 1 into minus 8, z minus 2 into 6. So you will have minus x plus 4 minus 8y minus 8 plus 6z minus 12 is equal to 0. So I think we are getting the same answer, right? Minus x minus 8y plus 6z. So 4 minus 8 is minus 4. Minus 4 minus 12 minus 16 is equal to 0. So if we multiply with minus, we are getting the same answer. Okay, so we can use any one of the methods. So that's it. So we have solved subtopic 2 and 3. Again, subtopic 4 is starting. We have solved subtopic 3 and 4. Subtopic 4 is not yet over, right? So we have solved 10 problems in subtopic 3, 4. Now we will continue solving more problems on subtopic 4 in the next class. Okay? So I will post recorded videos soon, and I will post these notes also in Telegram group. So if you need doubt, you can ask, or you can leave them.